So the first thing we want to discuss in alkanes is its structure or the formula of alkanes, right? So an alkane is basically a saturated compound, which means that it has only single bonds, right? It's completely saturated. All of the bonds have been taken up, like the carbon has formed all of its bond, and you cannot add anything else to it. Nothing can be added to an alkane, but you can replace atoms in an alkane. So you can replace these hydrogens if you like. So you need to know that you obviously have your straight chain alkanes, right? You also have cycloalkanes, so they look something like this, right? So this is let me draw that again. So this is a cycloalkane, right? So this is a 6-membered ring. It's not like any of the bonds are shorter, it's just a problem with the way I draw. So it's essentially like this, right? All of the bonds were equal length. Please forgive my drawing, and all of them would have hydrogens on them, right? So this is a cycloalkane. So we would mainly be looking at reactions of straight chain alkanes, and that is what we will be talking about for the rest of the video. But obviously you could have those reactions in cycloalkanes as well. So let's look at some of the reactions of alkanes. The first one we're going to talk about is cracking. So cracking is how smaller and more useful alkanes and alkenes are obtained from larger fractions. And that is what we're going to see in a minute when we talk about fractional distillation. Anyhow, the concept is whenever you have a larger hydrocarbon, for example, in this case, we have an hexane. So that can be broken down to produce things like butane and ethene. Ethene, which actually is a very important component. So this is ethene, which is an important component for plastic, right? So what is the conditions for this reaction? Well, the temperature needs to be really high. So we're talking about 650 degrees Celsius, and it's usually passed over a catalyst. So this is heated up at 650 degrees Celsius, and it's usually passed over a bed of catalyst of aluminium oxide. So an important application of cracking is usually in the oil industry. So that is what it's called fracking, because it's done in a fractional distillation column. As you can see from this video that I've taken from the American Petroleum Institute, the vapor rises into this column. So this is basically crude oil vapor. It rises into the column, and then different fractions are separated at different temperatures. The fraction right at the top, gasoline, is actually the lightest fraction, and it vaporizes at the lowest temperature. So it travels way up the column. And then you have naphtha and heavy oil. So the heavier components stay at the bottom of the column. So cracking is usually done so that we can obtain more useful components from heavy crude oil. So the bonds are usually broken, just like we'd seen in our cracking example. So the bonds of the carbon atoms are broken down, and then it's converted to smaller components. That's it you need to know about cracking. So the first reaction you need to know in alkanes is combustion reaction, which is quite simply the burning of alkanes. So what happens is you can have any alkane. So you would have an alkane plus oxygen. And whenever you have a complete combustion reaction, you would end up with carbon dioxide and water. So suppose if I have a CH4, it burns an oxygen and it gives me CO2 plus H2O. Now this needs to be balanced out, so let's check this. So this is 4 hydrogen here, this is 2 hydrogen here, 1 carbon, 1 carbon. So what I can do is I can make this 2. So that would make it 2 oxygen, right? And 4 hydrogen. So I can just add a 2 here. And that makes it balanced. So that's all you need to know about combustion reactions. Make sure you know how to balance equations. You can go back to my video on balancing equations. You also need to know about something called incomplete combustion, right? So we just saw what is complete combustion, that gives you carbon dioxide and water, but incomplete combustion can basically give you the opposite. Incomplete combustion happens when you do not have enough oxygen, when there's insufficient oxygen. So incomplete combustion would give you carbon monoxide and water. And this carbon monoxide is poisonous, and it's really bad for the environment. The next is substitution reactions. So a substitution reaction is essentially when you substitute one of the atoms with another one. So for example, if I had a methane and I substituted this with a chlorine, and I ended up with a halogenoalkane, right? So this is called a substitution reaction. But in this case, this reaction does not happen in the dark. It happens only in sunlight. So you can actually do this experiment in the lab. So you would need 2 test tubes, right? Both of them containing, say for example, hexane. And to this, you need to add bromine, right? So initially, both of them are orange colored, right? Because bromine is orangish brown when it's a liquid. So both of them are going to be this color. Yeah. Now, when I leave this in 2 different conditions, so one of them, I'm going to leave it in the dark. And the other, I'm going to leave it in light, right? So what do you think is going to happen? Well, the one that you left in the dark is actually still going to have that orangish brown color. But the one that was left in light is going to have a reaction, and it's going to become, basically the bromine color would disappear. So you wouldn't see a color here. So this reaction, this particular reaction, only happens in sunlight. And you actually need to know about this reaction in details. So the actual title for this reaction is free radical substitution. So this is a free radical substitution reaction, and you need to know the 3 steps of a free radical substitution. So what are the 3 steps, you may ask? Well, the first one is initiation, which is basically the start. And then you have propagation, and then termination. So let's look at them one by one. It may look overwhelming at this point, but it's quite simple. So the first thing is that a chlorine atom splits open. A chlorine molecule, the bond is broken. What does that mean? So when you have a chlorine molecule, such as this one, they equally share electrons between them, right? So the bond, as obviously, would contain 2 electrons, right? 1 from each of the chlorines. So what happens in this case is it undergoes bond fission, right? So the bond breaks down. So this breaks down, and you end up with a chlorine radical. So each one of these chlorines would take their electrons with them, right? And this is highly unstable. Radicals are highly unstable, and they will go around and create a chaos and attack everything in sight. So that's what chlorine does in this case. So the chlorine goes about and attacks the alkane, right? The CH4. When it attacks the alkane, it actually turns it into a radical itself. So the CH4, the poor old CH4, has now become a radical. So it's now a CH3 dot. So now because it's been radicalized, it's actually going to go and attack other molecules, so such as this chlorine. So when it attacks this chlorine, now see what happens. You end up with a CH3Cl, so now he's happy, but then he's produced another radical, right? And that guy is going to go back and attack another halogen alkane. So essentially, the reaction just keeps going on and on and on. But it doesn't keep happening forever. It has to come to an end. So what happens? You have the termination step. So what happens in termination is essentially two of the radicals combine and they find peace. So you could have a CH3 combined with a Cl dot, right? And you could have a CH3Cl, or even a Cl could combine with another Cl and give you a Cl2. All of those are termination steps. So let's move on to the next equation that you need to know of, and that is addition reactions, right? So this is the formation of alkanes that we're talking about, because obviously alkanes are saturated. We saw in the first slide of our video, alkanes are saturated compounds. They have all single bonds, so nothing can be added. You can only replace atoms. Okay, so this is an alkene. By now you should know, because it's two carbon atoms, we're talking about ethene, right? So when you have hydrogen being added, so hydrogen can be added either over palladium or a platinum catalyst, right? And then you will end up with ethane. So you will break that bond, you will break that double bond, and you will add hydrogen over it. So this is also usually a bed of palladium or platinum catalyst. And then the molecule basically comes in, it attaches onto the bed of, the catalyst, and the hydrogen gets added, and then the molecule gets released. Okay, so that is the addition, and that gives you an ethane molecule. Yeah. Well, that is all you need to know in alkane chemistry. Thank you for watching. See you next time.